Start. Welcome once more. At least now the number has gone up, even though it's not.
Then test two. Test two. Test two.
Test 2 you're going to write on the 9th of September. I think it's going to be on Friday, isn't it? But you have the dates. Didn't I send you the dates?
No, you did. I was just confirming.
Oh, okay, it's fine. Okay, let's start. Let's quickly go to our window journal so that we can start with our lecture. So today we're going to do example 4.7. Is it 4.7 or 4.5? Let me check. Yeah, example 4.7, page 30 on your lecture notes. So if you can quickly go there to your lecture notes, then this is the continuation of example 4.1, if you still recall. And in this example 4.7, we're going to consider table 4.2, which consists of the number of households viewing show X. Sorry, there is somebody who's making noise there. Can you switch off your mic, please? Okay, thank you very much. I was saying that we are going to consider table 4.2. That table is on page. Let me just check it for you. Yes, on page 29, table 4.2. It's going to get some of the information from that table in order to calculate the overall sample sizes and the sample sizes for each stratum given the desired bound at a minimum cost. So now this lecture number 14. Lecture number 14. So we're going to do example 4.7. Okay. So like I said, we are going to consider table 4.2. Table 4.2, which consists of the numbers of household viewing show X. Okay. So table 4.2, it has stratum 1, 2, and 3. Okay. There's stratum 1, 2, and 3. With the sample sizes for each stratum, it's n. Stratum number 1 is 20. Stratum number 2 is 8, and then 12. So stratum number 3. Then the number of household viewing show X, represented by X, is equal to, for stratum number 1, 16. Stratum number 2, 2. Stratum number 3, 6. Then we were supposed to estimate the population proportion for each stratum, which is what? Pi hat. Okay. Now we've already done that. To calculate the population proportion for stratum number 1, you have to take 16, then you divide by 20, then you get 0.8. We did it last time. Then for the estimated population proportion for stratum number 2 is 2 divided by 8, which is 0.25. For those who were not there, for the estimated population proportion for stratum number 3, find that is 0.5. Those are the information that we want to use. Okay. Now, remember, like I said, this is the continuation of example 4.1, where we have got a population. We have a population there, to remind you, of 310. Sorry for that. 310, which is divided into 3 stratum. Stratum number 1, we've got town A, then number 2, town B, then the third one, we've got rural area C. So we've got rural area C. So now, the population size of town A, or stratum number 1, is N1, which is equal to 155. Okay. For stratum number 2, which is N2, is equal to 62. Okay. For stratum number 3, N3 is 93, if you still recall. Then the estimated population proportion for stratum number 1, which is P1 head, like I said, from that table is 0.8. And then the estimated population proportion for stratum number 2, 0.25. Okay. For stratum number 3 is 0.5. Okay. So now, if you can check that example 4.7, they have indicated that the cost of obtaining observation is $9 for either town. Okay. So in other words, for stratum number 1, we're going to have C1, which is the cost of stratum number 1 is $9. The same applies to stratum number 2, which is town B. It's also $9. So C2 is going to be 9. And then $16 for the rural area. And then here we've got the cost, minimum cost, C3 of $16. Now, the numbers of households within the strata are the population size N1, N2, and N3. We've already indicated there. So now the firm wants to estimate the population proportion, which is P, with a bound on the error of estimation equal to 0.1. In other words, our B is equal to 0.1. Okay, and our D is equal to B squared over 4, because we want to estimate the what? The population proportion. Okay, so that's it. I think that's the given information. So the formula that we're supposed to use for calculating the sample sizes for each stratum, if you still recall, is Ni, which is equal to Ni times the square root of Pi Qi. Okay. Then you divide everything by the summation. Because you have got 3 stratum, So that means I is ranging from 1 up to 3 there of Ni times the square root of Pi Qi. Oh, sorry, here up there, the numerator you have to divide by the square root of Ci. Okay. So even here you have to divide by the square root of Ci. Okay. Then, because this is the sample size for each stratum, so you have to multiply it by the overall sample size, which is N. Okay. So this is the formula that we're supposed to apply. So now, if you still recall, we have another formula for finding the sample size for each stratum. Okay. Which is Ni equal to, you can tell me. In other words, it's the sample size for each stratum, which is the same as this one. So now it's this one can also be equal to AI times N. So in other words, this formula is the same as this. So Ni can also be equal to AI times N, where AI is the what? Represent the fraction of observations, isn't it? So now, from this case, now our AI is equal to what? Sorry, fractions of observation is equal to what? Who can tell me? If Ni is equal to that formula, big formula, multiplied by the overall population size, overall sample size, sorry. So if Ni again is equal to Ai times N, so our Ai is equal to what?
Isn't it not equal to that big formula up there?
Yes, very good. So that means our AI is equal to Ni times the square root of Pi Qi divided by the square root of Ci divided by summation I is ranging from 1 up to 3 of what? Ni times the square root of Pi Qi divided by the square root of Ci. So this is our AI. So now,
Sir,
in this, yes.
that division, are you only dividing the square root of Pi and Qi or everything?
But anyway, you can see that there is a summation and there is a multiplication. There is no addition, there is no subtraction. It's dividing everything. Ni times the square root of Pi divided by the square root of Ci. You get it?
Okay.
Yeah. So now, what we have to do now is to calculate AI before you calculate any sample size for each stratum. So you have to calculate AI, which is the fraction of observations. So where do you start? So in other words, what I'm saying is you have to find A1, A2, N3, A3 because there are 3 strata. In other words, you are supposed to find A1, which is equal to N1, okay, times what? The square root of P1, Q1, all divided by the square root of C1, isn't it? Then you divide it by what? By summation of where I is ranging from 1 up to what? 3 of what? Ni square root of Pi Qi divided by Ci. to calculate the fraction of observation for stratum number 1. So you have to use this one. So the same applies to A2. So for A2, again, you are going to have what? N2 square root of P2 Q2 divided by the square root of C2. Then you divide by summation I is ranging from 1 up to 3 of Ni square root of Pi Qi divided by the square root of Ci. Okay, then you get the answer. The last one is going to be A3, okay, which is equal to what? N3 square root of P3 Q3 divided by what? Square root of C3. All divided by what? Summation I is ranging from 1 up to 3 of what? Ni square root of Pi Qi divided by square root of Ci. So this is what we are supposed to do. Now let's find the summation of so let's find this first, this one, because it's going to be constant for each stratum. So let's find that. And remember, this one now is equal to what? So you have to find what? N1 square root of P1 Q1, okay, divided by the square root of C1 plus N2 the square root of P2 Q2 divided by square root of C2, then plus N3 square root of P3 Q3 divided by the square root of C3. Then you give me the answer. So in other words, to make it easier, so you're going to get what? 155 times the square root of P1 Q1, because you know that this one also equal to what? N1 the square root of P1 1 minus P1, isn't it? Then you divide by the square root of C1. Then you do the same for this one, N2 P2 1 minus P2. Okay, then you divide by the square root of C2. Then you said what? N3 square root of P3 1 minus P3 divided by square root of C3. Okay. So can somebody calculate it for us, or you just want me to substitute? Don't have a space, so we have to go to the next page then. Sorry.
I'm having the denominator being 41.241. Can I please get confirmation?
Okay, let me just check. You're saying here, oh, can I write it down there? What you are saying is the summation I ranging from 3 of ni square root of pi qi divided by square root of ci is equal to what?
41.241.
41.241.
Yeah.
Everybody is getting the same answer because different from mine, a little bit different from mine. I don't know. I got 41.241.
Yeah, they're getting.
42
It
point
seems like they're getting the same thing.
40. Mine is this 41.281. So you got this one, isn't it?
Yes, I got that
Okay.
one, the first one.
Okay. All of you got 41.241. Or is there anybody who got 41.281?
I got 41.241, sir.
Oh, so that's me who made
I
mistake
think
there.
I think it's because of the rounding off, sir.
It's because of the rounding off. Remember, yeah,
Yeah,
that issue of
No,
rounding
I'm
off,
suspecting.
no. In
it's
this
not.
case, it's not, because
It's not.
it's 41.24159. When we round off, it's just that 0 tends to be 1. So
Okay. No. Let's
No,
go
my
one
sister,
by
I
one.
don't mean on the final answer. I don't mean on the final answer from above there. So if maybe you round off different numbers from up there, obviously it's going to affect your final answer down there.
Definitely. There.
if
So let's go back. Let's go back and do it like this. And tell me, what did you get there? So tell me, what did you get here? N1 times the square root of P1 Q1 divided by square root of C1. What did you get there? Just round it to 3 decimal places, isn't it? Let's see.
20,667.
Yes, it's what I got. Let me just write it down. 20.667. That's number one. What about this one?
8,949.
Yes, it's what I got. 8.949. So here,
11,625.
yes, it's what I got. 11.625. Can we add everything now? Oh yes, that's true. I think it's me who made mistake. I think so. It's 41.241, isn't it?
Yes, it is.
Yeah. So you are right. The correct answer is 41.241. So this one is out. Okay. Now you got your denominator, which is going to appear to each and every one. So what about the here? Oh, sorry. So now let's find A1 now. So it's complicated here now things. Let me just write it nicely down here. So remember we're finding A1. So which is equal to N1 the square root of P1 Q1 divided the square root of C1 then divided by ni square root of pi qi the square root of ci. Okay, and then what about the numerator? Numerator is what? Because here we are going to divide it by 41.241. What about n1 times the square root of p1 q1 divided by square root of c1? What did you get?
20,667.
Yes, it's what I got. So 20.667. So what is the answer?
0.5011.
0.5. Let's put it to 3 decimal places. 0.5 what?
01.
01. 501. Okay. Now let's go to fraction of observation of stratum number 2, which is A2. You know that is N2, A2, Q2, divided by square root of C2. Then we divide by summation of I is ranging from 1 up to 3 of Ni square root of Pi, Qi, square root of Ci. What is the numerator there?
8.949.
8.949. So what I got? Then the answer
0.217.
0.127. Okay. A3 is going to be N3.
Let's just substitute what
At
you got because we already
0.2.
have the formula.
Oh, okay. So it's fine. If you now you got it. Got the
Semo at
formula.
0.217. Like
Oh
it's
yeah,
0.217, not 127.
it's
Oh, 0.1.
0.217.
0.217. Okay.
A2.
Like this.
Yes.
So A3 is what? Numerator is what?
11.625.
Yes, so what I got it. So then divide by 41.241. The answer is what?
0.282.
0.282. Okay, now you have got A1, A2, A3. So now you can find the what? The sample sizes for each stratum. So now you can find the sample sizes for each stratum, which is equal to EIN. So now N1 is going to be 0, what? A1 is 0, 0,501. Okay. Then you multiply by n. Okay. So N2, or is this one? 0,217, you multiply by overall sample size. Then N3 is 0 comma 282. Remember, so here again you have got two unknown values, n1 and n, n2 and n, n3 and n. So you are supposed to find what? The overall sample size now. So we have to calculate that one. Otherwise, you have to find n. Okay. So n, if you still recall, is equal to what? Let me just write it here with enough space. N is equal to the summation. I is ranging from 1 up to 3 of ni squared pi qi. The overall size is sample size for estimating the population proportion divided by ai. Okay. All is divided by what? Overall population size being squared times d, and our d is b squared over 4, then plus the summation. I is ranging from 1 up to 3 because we're having 3 strata. Ni pi qi. This is the formula that we're supposed to use to calculate the overall sample size. So now let's start by calculating this one. Let's start by calculating this one. Then you have to give me the answer for this one as well, and then later the answer of this one. So in other words,
Sir,
yes.
what is the difference between the sample size of each strata and the sample size to estimate P?
Oh, this one is the overall. It's the overall sample size, and these ones are the sample sizes for each strata.
Okay.
So now we just want to find the overall sample size, so that you can substitute here. Okay. Then later is then that you can find what the sample sizes for each stratum, stratum 1, 2, and 3. So, but now I want you to find this summation of i's ranging from 1 up to 3 of ni squared pi qi divided by ai. Okay. Then find this one. Then later you have to find n squared b squared over 4. And the bound, remember, is 0,1. So in other words, it's 310, if I'm not mistaken here, multiplied by 0,1 squared divided by 4. So give me the answer there. Then later you find the summation I is ranging from 1 to 3 of ni pi qi. Those are the values that we were looking for. Let's start with this one. What is the answer?
Which one I start with, sir?
This one.
Sir?
Can you see this one?
This one.
The answer is 18661.
Wait. 18
661.
661.
661, yes.
Mhm.
Comma 63645.
Comma.
Comma 63645.
63645. Let's make it like this.
45.
Let's round it. Let's round it to 3.
Okay, it's like that.
So everybody got this like this. Did you get the same answer? Please make sure that you are doing it. Mr. Chimanga, switch off your mic. Did you get it? If you got it the same answer as this one, so just tell me that it's the same. Because in my case, it's going to be different because from up there, I got the
Mine is
wrong.
not the same.
It's not the same. What is yours?
I'm having 2062.145.
Hey, this is 2064.
So
Point what?
I,
The
I,
same.
I suspect mine is wrong.
Yours, I think is wrong, totally wrong. Because mine is 18686.457. I know that is going to be different with yours because remember at the beginning there, I used 41.281. You remember? So it won't be the same as yours.
This side I have 18661.63645.
18661.
63645.
Yeah, so it's the same as this one. Okay, so let's say this one is the correct answer. Now, find this one. Summation of NIPIQI. What is the answer?
59.675.
59.675. Let me check mine. Yes, but it's the same as mine, this one. Now this one is the same as mine. 59.675. Is there anyone who's getting the different one?
I got the same there.
Okay, it's fine. Now let's go to the bound n squared, bound squared divided by 4, this one.
240.25.
240 point 25.
25.
Yes, the same as mine, this one. Okay, now we are having everything now. So we have to plug it from the formula. Sorry. So that means our n, which is the overall sample size, it's equal to 18661,636. Okay, divided by 240.25 plus 59.675. Can tell me what is the answer now?
63. 63.
I need those commas. First,
62,221.
2,22. So obvious is going to be 63. Even mine, it was 62,304. Obvious is going to be 63. Remember, this is the sample size, so you have to round it off. As long as you have some decimal numbers there, round it off, please. So now we have got our overall sample size. What is left is what? Is to find the sample sizes for each stratum. Yeah. Is to find these ones. So you have to find these ones now. Okay. Because we don't have space there, let me just take it down. Let me just take it down. Okay, in other words, N1 is equal to 0,5 0.01 multiplied by 63. Then N2 217. N3 So tell me, what is our N1 now?
31.563.
Which is what? 32, isn't it? Okay. We will arrange them later if they are not giving us 63. Okay, let's go to N2.
13.671.
I think this one is 14. The next one,
17.766.
66.
Yes.
18. Can you add them? Are
63.
they giving us 63? Eh?
Yes. Yes.
Or
Yeah?
63?
No. 64.
It's 64, sir.
Oh, it is 64. Now, let's go back now. To round, like I said before, you have to start with, you have to check the decimal here. Let me just show you, okay? You have to check these decimals here. Yeah. Which one is the biggest one? The first one is this one, isn't it? Okay? Because it's 671. Hey, it's this one. Sorry, is this one 766. So that means this one is okay. You round it off to 18. Then you come to the second one. Second one is this one. So you round it to 14. So this one you leave it as what? As 31. Instead of 32, this one is going to be 31. So when you add them, are they giving you 63?
Yes, there's 63 now.
Yes, so now they are 63. So this is how you round it off. So this is the
Second, can you repeat that, sir? Especially on why do we leave it to 31?
Oh, okay. I'm saying here we were calculating the sample size for each stratum. Then we find that for stratum number 1 is 32, stratum number 2 is 14, 3 is 18. Then when we add them up, we find that they are not giving us 63, but instead they are giving us what? 64. Okay, then we go back to those decimal places. This one 766, 671, 563. Then we look for the one that is the biggest where. Here, if you check, 766 is the biggest of them all. And this one is the second biggest, 671. And this one is the last. Okay. Then you start from the biggest. Round this one first. 17.766 to be 18. Then you go to the second biggest, which is this one. You round it off to be 14. Then this one, because if you round it off, it's going to give you 64. So you just leave it like that as 31. So when you add them up, they must give you what? 63. That's what we did.
Thank you, sir.
Okay. So now we are done. We are done with this one. So now, if you can check your lecture notes there, for those who are having lecture notes, there is a 4.3. You see that on page 30. Post stratification is like this. It's written 4.3. Let me just use another color so that you can see it. 4.3. We call it post stratification. Okay, and additional what? Okay, but I'm interested on post stratification. So this one, this up heading called post stratification, we're not going to do this one. Okay, this one we're not going to do it. So that means 4.3 is out. The same applies to example 4.8 because it applies post stratification. Let's leave it, it's out. And then the same applies to example 4.9, sorry. 4.9 is what? Yeah, I think 4.9, I think. Okay, it's out. So in other words, 4.3, it's out. Example 4.8 is out. We're not going to do those things. Okay, you have to take note of that. Now let's go to the additional comments and on stratified sampling. So that one we have to know. So, but let's quickly go to the optimal role for choosing strata. How do you choose the strata? We're going to that section now. How do you choose the strata? Or how do you construct the strata? Okay, let's go there to the next page. It's an optimal role for choosing strata. Okay, I want to show you how do you choose the strata. How do you construct the strata? Okay, let's quickly go to that example there. Below that says we're going to use cumulative square roots of the frequency method. So, and they gave us the example with an intervals for those who are having it, but I will write them down. You have the intervals, okay. You have intervals, okay. They started from 100. Interval number 1 start from 100 to 150, okay. Number 2 is 150 to 200. Then 200 to 250, isn't it? Then like that until the last one. We are going to have how many? Kth interval, isn't it? Because you know that k represents the number of intervals. So we're going to have k interval down there. Okay? Like this. So we have an interval. From there, you're supposed to have the frequencies. Okay? Frequency, let represented by Fi. Okay? So that means for interval number 1, you're going to have frequency number 1, isn't it? Interval 2, frequency 2, then frequency 3, then you go like that. So that means the last one is going to be what? Fk, isn't it? Okay, so that's it. That's column number 2. So the third one, you square the frequencies. Find the square root of those frequencies. Square them. Okay, that means for interval number 1, you're going to have the square root of what? F1. Then square root of F2. Then square root of F3. Like that. So the last one is going to be what? The square root of Fk. Are we together? Okay. Then from there, you find the cumulative frequencies. Cumulative of what? The square root of Fi. Okay. You know, when you want to find the cumulative, so the first, for the first interval, so you're going to have what? The square root of F1, isn't it? To find the second one, what do you do? Who can tell me? To find the cumulative frequencies. To find the cumulative for the second interval, how do you do that? If you still recall.
You add the first one, the second one.
Come again?
You're going to add the first one
You
and the
take,
second one.
yeah, you take the first one, you add to the second one. So it's F1 plus square root of F2. That is the cumulative frequency of interval number 2. For number 3, you do the same. You take the F1, you add F2, you add square root of F3. That is how you do it, isn't it? Then when you go down there, the last one is going to be what? The sum of what? The square root of the cumulative total, sorry. It's going to be the cumulative total of the square root of f, which is what? Which is represented by t in this regard. That is the last one. So now, remember, we just want to construct the stratum. That is the main idea here. Okay, then this column is done. So now, when you are done with the cumulative frequency, then you draw a bound for the first interval. This is the first interval. You draw a bound here. Just write it. A line there. Okay, that is your bound. Then second interval, again you draw another one. Then you draw another one. Then the last one you draw another one. So I will show you how do we end up drawing the bound. What are the information that we're supposed to have in order to make sure that, okay, column number 2 or interval number 2, we have to draw a bound there. Column number 3, we have to draw a bound there. You will see when we use the numerical example. So this one is just the general information that I'm giving you on how to construct the strata. So after you've done that, draw a bound all, then you join them. Bound this one and this one, you join them together. This one and this one, you join them together. And this one and this one, you join them together. So how many stratum are you going to have? Strata are you going to have? 3 of them. So this is the first one. Okay? Stratum number 1. This one is stratum number 2. And this one is stratum number 3. Okay? When you are done with that, you have to just say, okay, stratum number 1, let's write it nicely now. Sorry. Okay, let's write it nicely. So you have got stratum 1. Okay, stratum 2 and stratum 3. According to that, we have 3 of them. So stratum number 1, in terms of the interval, if you check, it started from where? From 100, isn't it? Up to this point, up to 300, up to 200. Sorry, that's stratum number 1. So you have to write it like that. So it's 100 to 200. So stratum number 2, obviously, is going to start from what? 200 to 250. So this one is going to be 200 to 250. That's the last one. Obviously, is going to start from 250 to the last one. In this regard, I call it the kth interval. Like I said, this is the general way of doing it, of constructing the strata. Okay, now I think you have this information in mind now. So let's quickly go to the example, numerical example on page 33. Example 4.10. We just want to apply this, what we have been doing here, because here I was just giving you the what? The general information on how to construct the strata. So here we have got the example, yes.
Stratum 1, isn't it 100 to 150?
You said what?
100 to 150.
You said in stratum number 1, it was supposed to be 100 to 150. That's what you're saying.
Yes.
Okay, let's go back. Maybe you made a mistake. No, it can't be 100 to 150. You see, this is interval, isn't it? It started from 100. 100 to 150 is this one. Okay, it's this point. So now stratum is we join this bound and this bound together. So in other words, we are having this position. So in other words, we are starting from 100, going to what? To 200. So that is why we're having this one. You can't just say it's 100 to 150 because it's like this. It's not a stratum, this one, it's just a bound. You join 2 bounds to become a stratum number 1. So that is why we join this one and this one. It becomes stratum number 1. Now we started from where? From 100 here. And then ended up to 200, not to 150. So the same applies to stratum number 2. So if you check, it started from 150 here. It can't be started from 150. It started here, going down to this point. So it's this one, then to this one, and so on. So let's quickly go to the example on page 33, example 4.10. We have an example there. For those who are having a lecture notes, page 33, example 4.10. It says an investigator wishes to estimate the average yearly sales for 56 farms. Okay, that is the population size, isn't it? Using a sample of n equal to 15 firms, or firms, not farms. Then frequency data on these firms is available in the form of classification by $50,000 increments and appears in table 4.5. So this table 4.5 is the one that we are going to consider. Now the question down there below that table, it says what? How can we best allocate firms to L equal to 3 strata? Okay, so they tell us that our number of strata, there are 3. Let me say example 4.10. So we need this table. Let me just write it down quickly. But we don't need it because all the calculations are there. We have got the income in thousands intervals. We have the frequencies. We have got the square root of frequencies. We have got the cumulative frequencies. Is it necessary to write it down? Is there anyone who doesn't have the lecture note with him or her? Can I copy it down here?
Yes, sir.
Okay, it's fine. Let me just do it. We have a table 4.5, which represent the income in dollars. It's in page 33 for lecture notes. So because the space is too small here, let me just go to the next page. Okay, so you have got the income in intervals. Income in intervals. It's 100 to 150, 150 to 200, 200 to 250, 250 to 300, 300, 350, 350, 400, 400, 450, and the last one is 450, 500. Those are the intervals that we're using. Okay. Now follow the frequencies. Fi. We've got interval 100 to 150. We've got 11 of them. Then 14. Then we've got 9, 4, 5, 8, 3. The last one is 2. Then you find the square root of that. In other words, when you square 11, you're supposed to get what? 3.32. This is how they've done it. So square root of 11 must give you 3.3166 and so on. It's 3.32. So this is how they managed to find it. It's the square root of that and the square root of I. So here is what? 3.32. This one is 3.74. Then 3.00. 2. Then square root of 5 is 2.24. Square root of 8, 2.83. That other one is 1.6. 0.73. Then the last one is 1.41. Okay. Then they find what? The cumulative frequency. The cumulative of the square root frequency. So cum of the square root of fi. Okay. In other words, it's the first one is going to be 3.32, isn't it? The second one is 3.32 plus 3.74. It must give you what? 7.06. Let me just check. It's 3.32 plus 3.74. 7.06, yeah. This is how they got it. So it's 7.06. Then the next one, they add 3.32 plus 3.74 plus 3. They ended up getting what? 10.06. The next one like that is going to be 12.06. Then 14.30. Then the next one 17.13. Then follow 18.86. Then the last one is 20.27. So this is the table that we are having on page 33 on our lecture note. Okay, now we have this table. Remember, our main idea is to allocate the firms in 3 strata. No, in other words, we're supposed to have 3 strata. Stratum number 1, stratum number 2, and stratum number 3. How do we do that? So now the first thing to do, you have to write the number of stratum. L. L is equal to 3. It's given there, isn't it? Then later, you find the cumulative total. Cumulative total, in other words, is our T. Like I said before, it's cumulative total of the square root of frequency. And cumulative total there is what? You can tell me if you understood the previous example. What is our total there?
20.27.
Yes, thank you very much. 20.27. That is our total there. Okay, now, then later you find our K. What is our K stand for?
Sir, can you go up a little bit? You'll come back just a second. Thank you.
Okay. So K stand for what? You can tell me. I said K stand for the number of intervals. How many intervals do we have there? Are we still together?
There are 8, sir.
8. Okay, thank you. Then those are the information that you're supposed to have anyway. Even though that K, I think it doesn't have any effect today. But the rest, they do. Now, the first step that you have to do now is to find T over L. T over L. Calculate T over L. T is equal to what? 20. L is what? Is 3. What is the answer there? Answer, please.
6,757.
6,757. That's the value, isn't it? The value that we got. Now, you have to compare this value with the value that is very close to it on the last column number 4. Can you look for the value that is very close to this value? Very, very close to this value. Which one is that?
The second interval.
The second interval. So that means what we have to do, initially we were supposed to draw a bound before we start calculating anything. Okay? Before calculate anything, that is our bound. Okay. Now, another bound is the value that is close to the value that we got. He said it's this one, this value. So now we draw a bound next to that value because it's very close to the value that we got here. To this value. Okay. Step number 2, you find 2 times total, then divide by R. So in other words, it's 2 times what? 6,757, isn't it? And what is the value of that? 13 point.
That's 13.514.
Okay. Go back to the interval, the value that is very close to it. Oh, sorry. Which one is that? The value which is very close to that is what?
12.
Is that 12? Are you sure it's 12?
It's
14.
between
Even that one of
I think it's this one. Then next, again, you have to use 3 total times R. And what is the answer? It's going to be 3 times what? 6,757. What is the answer?
20.271.
20.271. The value close to that one? Obvious is the last one, isn't it? It's this one.
20.27.
Then after doing that, you join those bounds. What is happening here? So therefore, it's this one, and this one. So in other words, this one is stratum number 1, and this one stratum number 2, and this one stratum number 3. Then you write it nicely down here in terms of the intervals. Oh. Hey, what is happening? You have to write stratum 1, stratum 2, stratum 3. So stratum number 1, obviously starting from 100. To 200. Okay. There's number 2. Obviously, it's going to start from 200 to something, to 350. 200 to 350. Then the last one, obviously, is going to start from 350 to, I think it's the last one. Yes, to 500. To 500. So this is how you construct the strata. So I think you can stop here. I didn't even give you the break. So let's say we stop here and then we continue from here tomorrow. Any question?
Sir,
Yes.
yeah, can you kindly repeat from whereby you drawn the bounds and whereby you are closer to this one? Hey, I was lost there, sir, from there.
Okay. Starting here. From drawing all those bounds, ne?
Yeah, from
But
drawing
the
the bounds and the calculated value and comparing.
okay, now I think you understand the table because I even explained how do we construct this table. I think that one I'm sure that you understand it. Okay, let's go to the bound. Normally, remember, we just want to find to allocate the firms to 3 strata. Okay, so now before you do anything, if you have that type of a table, because sometimes I can just give you the what, the income and the frequencies. Then you have to find the square root of the frequency. Then you find the cumulative number of square root of frequencies. That one I know you can do it. So now when you are done with that table, so the next thing is to draw a bound. Okay, to draw a bound, initially you have to just to draw a bound for the first interval. You don't have to calculate anything. You just come here and draw a bound for the first interval. That's number one. Number two, you have to find the number of stratum, which is L equal to 3. Then you have to find the total. So the total is down here. That is the total. You just take this value and put it here as the total. Okay. Then next we find the number of intervals, which doesn't have any effect because we didn't even use it there. So then after getting that information, then you use this, can I call it a formula? T over L. We use T over L so that you can know where do we draw a bound. Okay, the second bound, because the first bound you just go there on the first interval, you draw it. To draw the next one, you have to use this formula now. T over L, T is the total, L is the number of strata. So which is equal to 20 divided by 20, 20,27 divided by 3. And the answer is 6,757. So this value now, you go to column number 4 and check to the value that is very close to that. So when you go there, we realize that, okay, we realize that this value here, 7,06, is very close to 6, this one. Okay, then we draw a bound next to it. Then we draw a bound next to it. That is why we draw this bound. The next one. The first one is this one. The next one is this one. Okay. Then we continue and use this formula now. 2t over L, which is 2 times 6,757, and the answer is 13,514. Then we look for the value again, which is the closest to that one. Then we find that is 14. Then we draw a bound next to 14. Okay. Then we continue because we realize that if we stop here, we are going to have only 2 strata, and we need 3 of them. So that is why we continue to use this formula now. 3t over L, which is 3 times this one, and the value is this one. Okay. And we look for the value that is very close to that. And we realize that, okay, it's the last value, it's the total. Then we draw a line or a bound close to that value. Then after doing that, we join them up. We join those bounds. We join them. That is why we join this one and this one, and then later we join this one and this one, and then we join this one and this one. Then after that, we realize that, oh, we created some stratum now. This is stratum number 1. So this is stratum number 2. This is stratum number 3. Okay. This is how we did that. So it depending to the number of stratum according to the question that they say L equal to 3. If they said L equal to 4, we were supposed to go further and find what? 4T over L and find the value and so on. I think it's clear. Okay. Now,
Yeah,
can
yes,
we
thank you,
stop
sir.
here? Okay, thanks. Can we stop here? Like I said before, Mr. Ibas is going to send an email or a message on where and how and when can you collect your script. So just to be watch out, make sure that you are next to your devices. When he send that message, then you quickly and then you respond in that regard. So the tests are ready. We are just waiting for Mr. Ibas to send you the message so that you can just go and collect. And then, like I said, the test was fair because the highest got 93%, and the overall pass rate is 69, which is a great improvement compared to the last semester, where the first test was 45, I think, 45% pass rate. So this time around is 69. So it shows the great improvement. So we'll see on the second test how are you going to respond. So can we stop here?
So what's the test to score?
I will tell you as the times goes on. I will tell you. Obviously, it's going to start from what? From chapter 4, stratified random sampling, I think. Going forward, where I don't know where we are going to stop is where the scope is going to stop.
So is Mr. Ibisi going to teach us?
No. You are going to be with me throughout.
Okay. Thank you.
Yeah, I think we can stop here.
What about the tutorial of today? Are we having it?
Oh, today, I'm sorry for that. Yes, thank you so much for reminding me. Today we are going to have, I'm going to invigilate from 2 o'clock until 4. So I won't be able, because we're supposed to start with our tutorial from 1 o'clock. And at 1 o'clock, I don't think, because we're still going to have a meeting from 11. I don't know at what time we are going to finish that meeting. And then from there, 2 o'clock, I'm going to invigilate. So I don't think we can have that tutorial. Let's say next time.
Oh, okay, sir.
Okay, sure.